Hi guys, today's video is going to be solving multi-step equations in which there are multiple terms that have a variable. So you see in this equation that I'm giving you, we have a negative 3x and we have a 2x. They are on the same side of the equal sign. So this video is going to deal with how do we solve equations that look like that. If you have an equation with a variable on the left side and the right side, that's another video. So look for one with variables on both sides. So first and foremost, you need to know that you can only combine, meaning add or subtract, terms that are like terms. So if you don't know what like terms are, although they're on your flashcards, they're terms that have the same base and the same exponent. So when I look at my equation, I know that negative 3x and positive 2x are like terms because they both have an x to the first power. We just don't write the first, right? So they are like terms, I can combine them. The way I combine them is I'm just gonna add their coefficients, or I would have subtracted if there was a minus sign. Negative 3 plus 2 is negative 1, and I keep my x, okay? So I'm allowed to combine those terms. Now I'm just gonna bring down everything else from my equation that I haven't used yet, and I have a two-step equation to solve. So I remember that my goal is always to get x isolated so that I can find out what its value is, and I'm gonna do that by using inverse operations. So I see that x is being multiplied by negative 1, and it's being added by 5. I like to get rid of the addition or subtraction first before dealing with multiplying and dividing. So we're going to go minus 5 on both sides. Why? Again, because 5 minus 5 is 0, so it would cancel out because 0 plus negative 1x is just negative 1x. Bring down your equal sign, 8 minus 5 is 3. I almost have the value of x, but not quite. See, I know what negative 1x is, but I want to know what the value of x is. So x is technically being multiplied by negative 1 here. So I'm going to do the inverse, which is divide by negative 1. And of course, as always, if I do it on the left, I have to do it on the right to balance my equation out. Negative 1 divided by negative 1 is 1, and 1 times x is just x. And 3 divided by negative 1 is negative 3. So my solution for this equation is x equals negative 3. So really quickly to summarize again, if you have more than one term with the same variable on one side of the equation, combine them if they're like terms, and then solve the equation as you would using inverse operations. We'll do one more example with some fractions because I think that once I throw fractions in, you guys think it's a lot harder, and it's not unless you don't know your fraction operations. So let's do one example with fraction. Let's say 5 plus 1/3 x plus 2/5 x equals 7. So again, I look at the left, I look at the right, I see, is there anything I can combine? Are there like terms? There are. 1/3 x and 2/5 x are like terms. They both have the same variable and same invisible 1 exponent. So I'm allowed to add them. Now, if you struggle with adding fractions, you've got to watch a video on adding fractions, right? Because if we can't do that, then we can't do the equation yet. So first get that down. On the side, I always like to do my arithmetic on the side. That way you don't kind of clutter up your equation work. You'll add your fractions. So I'm going to go through it quickly, but again, if you need fraction help, you should watch another video. But quickly, we need the same denominator. So we know that 15 is the least common denominator for 3 and 5. To get from 3 to 15, I multiply by 5, so I'm going to do the same thing on top. 1 times 5 is 5. To get from 5 to 15, I multiply by 3, so I'll do the same thing in the numerator. 2 times 3 is 6. So these two fractions are equivalent to these, but I can add now that I have the same denominator. So when I add these, I will get 11 over 15. So this simplifies to 11/15 x. I bring down my 5, I bring down my plus sign because it's a positive 11/15. I bring down my equal sign and my 7, and I continue as normal. So I'm going to subtract 5 from both sides, because again, I like to get rid of that constant number first. 5 minus 5 is 0, and 0 plus 11/15 x is 11/15 x equals 2. Final step. X is being multiplied by 11/15. So the inverse would be to divide by 11/15. But I don't have to write that. I could say we're dividing by 11/15, dividing by 11/15. But if you know how to divide fractions, you know that dividing by a number is the same thing as multiplying by its reciprocal, right? By its flip. So I don't have to write all this out. If you want, it looks a bit nicer, it's a bit easier to multiply both sides by the reciprocal. Dividing by a number is the same as multiplying by its reciprocal. Okay, this will cancel out. If you need to see it the long way, if you do 15 times 11 over 11 times 15, that will of course give me 1 because I'm dividing something by itself, okay? So I'll get 1x on the left side, and on the right, I can rewrite 2 as 2 over 1 because 2 divided by 1 is still 2, and multiply fractions straight across. So 2 times 15 is 30, and 1 times 11 is 11, and I'm going to go ahead and leave it just like that. X equals 30 over 11. So there are some examples of solving multi-step equations that have more than one term with a variable in it.